Garbage. Did you know that in the United States, garbage trucks pick up and haul away 120 million pounds of trash every day? That's enough trash to fill more than 60,000 garbage trucks and line them up from Los Angeles to San Francisco in one day. And most of that garbage heads straight to the landfill.
Hi, I'm Steve Summers. You may think that landfills are giant piles of trash, but as you'll see over the next few minutes, there's a lot more going on under all that trash than meets the eye.
We're going to dig through the garbage today and take a close-up look at the inner workings of your local landfill. You'll see that landfills are actually scientifically engineered systems with the potential to create power. They also have the potential to create controversy. Landfills don't last forever, but it may surprise you to find out what is filling them up and what happens to landfills once they're full. In other words, we're going to be talking trash.
You know, we as humans have always created trash, but how we deal with that trash has changed a lot over the years.
Our hunter-gatherer ancestors produced trash like we do today, but back then most of it consisted of animal skins and bones, food scraps, and a few broken tools. You see, in those days, people tossed their trash on the ground. Most of the waste was organic. That is, it came from living material and didn't take a long time to decompose. If the trash piled up too quickly, our ancestors simply packed up and found a new place to live. This worked okay until people began to settle in one place and build permanent homes. The piles of garbage grew with the size of communities. Since it was no longer practical to move away from the garbage, people decided to move the garbage away from them. Trash became particularly troublesome in the United States during the early 1900s. Masses of people left their rural homes for factory jobs in the cities. Trash often piled up in the streets and alleys. On any given day, you might see heaps of coal and wood ash removed from furnaces, horse carcasses, and animal waste on top of all of the regular household trash. Pigs and dogs roam the streets eating kitchen scraps tossed out of the windows and doorways. Eventually, people tired of rotting trash in the streets and epidemics of disease caused by these unsanitary conditions. Cities created trash collection departments. Horses pulled the country's very first garbage trucks. For the most part, the trash ended up in dumps or was burned.
But these dumps came under increasing criticism during the late 1940s and early 50s. They were unsanitary, they were smelly, wind blew the trash around, and rain falling on the waste spread contamination everywhere. The dumps also provided a breeding ground for rats and a fire danger. See, when trash breaks down, it releases a gas called methane, which can explode or ignite.
Experts turned to science and engineering to solve some of these problems, and the sanitary landfill was born. A sanitary landfill is a carefully engineered hole for garbage. This depression in the ground is also called a cell. While most landfills involve digging a hole, sometimes they are built above the ground. In a sanitary landfill, handlers dispose of each day's trash by spreading it into thin layers, compacting it with bulldozers, and then covering the waste with about 6 inches of dirt. Sanitary landfills eliminated many of the health worries caused by open dumps, such as odor, windblown garbage, rats, and uncontrolled fires. But by the 1970s, a realization dawned that simply covering garbage with dirt was not enough to protect our health or the environment. Ecologists had learned that contaminants from the waste were seeping out of the bottoms of landfills and into local water supplies. When rainfall or other kinds of moisture from nearby water sources seep into the landfills, they mix with dangerous chemicals such as paint, fertilizer, insect sprays, and cleaning products. This contaminated fluid is called leachate. Tainted groundwater has the potential to directly impact our health, and once groundwater is contaminated, it is extremely difficult to clean it again. Landfill managers turned back to science and engineering to correct these problems. The idea of compacting and burying the trash remained. But several other features were added to the design of the sanitary landfill to collect leachate and methane gas and keep any contamination from escaping. We call the new improved version an engineered landfill.
This is a brand new cell being built at Skunk Creek Landfill in Phoenix, Arizona. Now, the Holer cell is about 120 feet deep. Engineers determined the depth based on groundwater levels and the makeup of the soil. To kind of give you an idea of how deep this really is, follow the rock.
You probably can't tell, but the cell slopes down to one side. This is so leachate will flow in two collection pipes. The pipes carry the leachate to a pump where it is pumped out of the landfill. Before they can lay down the liner, workers use equipment to pack down the earth and remove any rocks or debris that could poke through the liner. Once the surface has been cleared and packed down, teams lay down what is called a geosynthetic liner. It contains clay materials also known as bentonite. Although very thin, the geosynthetic liner is the equivalent of putting down 2 feet of packed clay dirt. On top of the clay liner goes the plastic liner. These large black sheets are placed across the cell, much like you would hang wallpaper. A tiny machine is set along the seams. It moves up the walls of the landfill, welding the sheets of liner together, one seam at a time.
If something should break through this tough plastic liner, the clay underneath will fill up the hole and expand, sealing the leak.
Around the cell, you'll see a 2 or 3 foot trench. After the liners are in place, workers fill this trench with dirt and then cover the liner in 2 feet of dirt. But this isn't just any dirt. Workers have cleared the dirt of rocks or anything else that might puncture the liner. Once the dirt is in place, the city can start dumping the trash. But landfill managers will make sure that first layer of trash is made up mostly of paper and plastics. They don't want trash with bulky items such as tree stumps, branches, or metal objects that could punch holes in the liner.
Engineers hope that this cell will last the city 5 years. And when it's full, the city will install pipes to collect methane and then top the landfill with a lined cap. Some landfills, such as Skunk Creek, burn off the collected methane, but more and more facilities are harnessing that methane and using it to create electricity.
Skunk Creek Landfill sits in a place far from any groundwater or runoff from the rain. Before city leaders allowed this landfill to be constructed, they did several studies to make sure it was a suitable location. In the early days of landfills, though, cities located many of them in marshy areas or wetlands. They thought filling in the wetlands with trash and later burying it would help them reclaim unusable lands for development. Hence the name landfills. We are still paying the consequences of such mistaken decisions. Today, we know water is a landfill's worst enemy, and that wetlands provide a crucial role in our ecosystem and need to be protected.
While engineering was the focus of building landfills during the 1970s and 80s, today the focus is on using hydrogeologic studies to place or site landfills in safe locations.
Finding an ideal site for landfill means engineers must examine the amount of rainfall and its runoff pattern, along with the underlying makeup of soil and rock. They're looking for soil and bedrock that is watertight. In other words, a site where fluids would have difficulty making their way beyond the landfill's boundaries and into bodies of water. Yet they want a site where if leakage does occur, the geology is so simple you can easily predict where the waste will go. That way you can put down wells and capture the escaped wastes by pumping. Fractured bedrock would disqualify a landfill site because experts would not be able to find the waste once they escaped. Mines and quarries are also unacceptable most of the time because they often come into contact with the groundwater. This provides a major problem for some areas of the country. Much of Florida, for example, is geologically terrible for landfill sites. Building new landfills there is out of the question. There are other factors that limit where landfills can be located as well. Collection and transportation expenses account for 75% of the total cost of waste management, so landfills can't be too far away. And yet, they can't be too close, because most housing communities don't relish the idea of living next door to a landfill. Although engineered landfills are much safer than their predecessors, people are much more leery of living near them. Landfills also need quite a bit of space, more than 200 acres. Although only 70 acres actually gets used for the garbage itself, it takes a lot of room to house support areas, runoff collection ponds, leachate collection ponds, drop-off stations, and areas from which to dig soil. At some point, landfills fill up and have to be closed. Skunk Creek is nearing the end of its life. This cell being constructed now represents the very last one here. But a closed landfill still requires attention and constant monitoring. The city will have to monitor the Skunk Creek site for at least 30 years.
Once a landfill is closed, managers will look for ways to put the space back to good public use. But this poses some challenges. You can't have anything growing on top of the landfill that could break through the bottom liner.
That means large trees with deep-reaching roots are out. Foliage is limited to grass, smaller shrubs, and trees. You can't build any big structures on old landfills either. Many cities have transformed landfills into baseball fields, large parks, or golf courses.
Not all of our trash goes to landfills. And despite all of our progress of modern choices of what we do with our garbage are pretty much the same as they were for our ancestors. Burning, recycling, or dumping. But landfills in most cases represent the most economical choice for disposing of trash.
Some places use gigantic incinerators to burn trash. In the United States, we burn nearly 10% of our garbage. Most of these incinerators are waste-to-energy plants. That means they generate electricity from burning the garbage. But incinerating trash has some serious drawbacks. For one, it costs a lot of money. Also, incinerators create poisonous gases and toxic ash. Although the harmful gases get cleaned somewhat in scrubbers, harmful pollutants still escape through the smokestacks, and the ash that is left over must be shipped to a very safe landfill. As far as recycling, Americans only recycle about 10% of the trash thrown away. That's not nearly as much as we could recycle. But it's gaining. More and more communities are seeking ways to cut down on the amount of trash that goes into our national waste stream. Most large cities now have plants where workers sort and bundle recyclables so they can be sold to companies who make new products from them. Milk cartons have been transformed into park benches. Old car tires are being shredded to make cushioned mats for playgrounds, and scrap paper is molded into flower pots.
Still, by far, the vast majority of America's trash ends up in landfills, more than 75%. And the amount we throw away grows steadily. We're throwing away 3 times as much as we did back in the 1960s.
In terms of cost and environmental safety, the engineered landfill has withstood the avalanche of trash and remains the best way for now to get rid of unrecyclable waste. But with our growing amount of garbage have grown a number of misconceptions about landfill space. Over the years, stories about disposable diapers and fast food wrappers filling up our landfills have captured headlines. Others have warned we are facing a garbage crisis and are in danger of burying ourselves in our own refuse. Archaeologist William Rothschild has done much to clear up some of those major misconceptions.
Head them up, move them out.
Over the last 20 years, Rothschild and his team of garbologists have mined the depths of landfills from New York to San Francisco.
This landfill is probably the most important database for our civilization that an archaeologist could ever find. I mean, because all of the daily aspects of our lives, what we eat, how we clean, how we have a good time, it's all buried in here.
The study was done as part of the University of Arizona's Garbage Project, which was established in 1973. Rothschild employed a giant auger to drill into the deepest chambers of landfills so they could dig up trash from many years ago and study it.
The Garbage Project is a study by archaeologists today of contemporary, fresh garbage, whether we sort it as it comes out of people's garbage cans or whether we dig it up out of a landfill like this and sort through it. We're trying to look at today's society the way an archaeologist will in 1,000 years without waiting that long.
What Rothschild has learned is astonishing. The biggest crisis he found in the trash is that much of what we assume to be true about garbage is, well, garbage.
More Christmas stuff.
Look at this cute bottle.
Oh, cool.
He summarized his findings in 5 myths about garbage. Myth 1. When added up together, fast food packaging, polystyrene foam, and disposable diapers take up 70% of our space in landfills. The reality, according to the Garbage Project, is that those three ingredients occupy a grand total of closer to 3% of our landfill space.
Rathje speculates that fast food packaging foam and disposable diapers are very visible among casual litter and became powerful symbolic targets. But if they disappeared from our landfills tomorrow, landfill operators wouldn't even notice.
Myth 2. Plastic is also a big problem. There is no question, says Rathje, that a larger number of physical objects are made of plastic today than in 1970 or 1950. But strangely enough, the proportion of space taken up by plastics in landfills has either decreased or remained right around 16%. Rathje says this appears to be because of lightweighting by plastic manufacturers. The process allows companies to make the same objects with less material. The lighter materials are easier to crush, so they take up less space in the landfill. What's really taking up all the space in landfills is paper. Plain old paper accounts for more than 40% of a landfill's contents. Newspapers alone may take up to 13%.
Right now, what we're standing on is 40 to 50% by volume paper. All kinds, whether it's newspapers, packaging paper, non-packaging paper like computer printouts or phone books. All of this stuff is a huge quantity in landfill.
Myth 3. A lot of biodegradation takes place in modern landfills. Although paper takes up a lot of space, at least it biodegrades, unlike plastic.
Now, when we started digging in Tucson, and then we dug a landfill in Phoenix, people said, well, of course it doesn't disappear because you're a dry, arid environment. So then we dug in California and Illinois and Florida, which gets 80 inches of rain a year, not really arid, and we found the same kind of pattern, that food debris and yard waste, about 50% of it will biodegrade in the first 15 years, and then it stabilizes. In terms of paper, we don't have any good information that any of it biodegrades because it's there in the percentages that it should be from the 70s, from the 60s, from the 50s, etc.
Rathje's team came across whole ears of corn, onion peels, and newspapers proclaiming headlines from the 1930s.
I'm reading this. This is where I get my information. Some people use USA Today. I use 25-year-old Palo Alto Times.
The measures taken to seal landfills and keep them from leaking contaminants also help ensure very little biodegradation takes place. The better designed and managed the landfill is, the less biodegradation. Myth 4. America is running out of safe places to put landfills. In some places of the country, as we mentioned earlier, this is true, but overall there is plenty of physical space for landfills. A Washington-based think tank, Resources for the Future, conducted a study of landfills. Economist A. Clark Weissman calculated that at our current rate of trash generation, all of America's garbage for the next 1,000 years would fit into a single landfill space only about 120 feet deep and 44 miles square. That's about the size of 3 Oklahoma cities.
The reason for the misconception about landfill space has to do with statistics. There are less landfills open today, and the number is shrinking. But the decreasing number of landfills has to do with the fact that the trend today is towards building bigger landfills, though less of them.
No, the real obstacles to opening more landfills are psychological and political. Nobody wants a landfill in their backyard, and it's becoming politically harder and harder to cite a location for landfills.
It's going to be very hard to cite landfills, and that's because in the United States, people have the right to complain about any kind of potential hazard or problem to their property value being located near their homes.
Myth 5. On a per capita basis, Americans are producing garbage at a rapidly accelerating rate. Make no mistake, Americans throw away a lot of trash, but not necessarily more than previous generations. Rathje points out that many things that used to make up our garbage no longer exist. For instance, we don't see the 1,200 pounds per year of coal ash that the average American generated from home stoves and furnaces at the turn of the century. We no longer see the 20 pounds of manure that each of the more than 3 million horses living in cities produce every day, or the hundreds of thousands of dead horses that cities had to dispose of every year. We do not see all the food that households once wasted because refrigeration and sophisticated packaging were not yet widespread. It's undeniable that Americans as a whole are producing more municipal solid waste than they did 50 or 100 years ago. But this is largely because there are more Americans than there were 100 or even 50 years ago. The bottom line is the amount of trash we're generating has remained steady. But Rothg says we shouldn't feel too reassured. All his research means is that we may not be as bad as we thought or our problems as terrible as believed. Garbage disposal is still a matter in need of serious attention.
I think that the real problem is that we're going to have landfills no matter what. If you recycle, let's say, a tremendous amount of sludge and other kinds of materials are generated from recycling paper. That has to go to a landfill. If you incinerate, you're going to reduce the volume in that incinerator by 90%, but 10% still has to go somewhere.
The facts are these. Our solid waste stream has not burgeoned into a raging torrent, and our means for disposing of garbage in landfills through incineration and recycling have never been safer or more technically advanced. But as political and civic opposition to opening new landfills grows, people are not willing to live with landfills in their backyard. To avoid this impasse, we need to make the landfills we do open last longer.
Places such as New York City, for example, which is hemmed in by suburbs, will probably have to turn to burning more of its garbage or paying other states and cities to take it. Phoenix, on the other hand, which is surrounded by open country, can probably rely on landfills forever. Rothg suggests cities should charge prorated fees for the collection and disposal of non-recyclable garbage. Charging a fee for non-recyclable garbage thrown away while not charging for recyclable refuse causes recycling rates to improve while cutting down on the volume of non-recyclable trash. When adopted on a broad scale, the impact ripples backwards as manufacturers use less packaging while keeping recycling in mind. Seattle has adopted such a system with much success.
We as individuals can do something too. We should buy goods and packaging with a high recycled content. Of course, the biggest problem faced by recycling is not figuring out how to turn something into something else, as anything can be recycled. And it would be if the demand for what it could be recycled into were great enough.
Everyone has accepted recycling as perhaps the most responsible thing they can do as citizens. But they believe that recycling is taking their newspapers and putting them out by the curb, or their corrugated or whatever else. And that's only half of it. That's only the beginning of the loop. What they have to do next is buy something made out of recycled paper, recycled glass, corrugated, etc. That's what they have to do to close the loop, and that's going to make a real difference.
To close that loop, we have to become garbage literate. Labels can be tricky. Did you know the word recycled on a package does not mean a product has been made out of something that was recycled? It means that it's been made in part with scrap left over from the normal manufacturing process.
The label you want to look for is post-consumer recycled. Ideally, the label will include a percentage such as 30% post-consumer recycled, but anything over 10% is good. Another possibility for the future is to keep improving on landfills. The latest idea being perfected by scientists and engineers is the bioreactor landfill. A bioreactor landfill involves infusing the buried waste with oxygen and moisture to cause quick but controlled decomposition of organic materials such as food and paper products. As decomposition takes place, methane forms and is harnessed into power. Bioreactor landfills combined with recycling have the potential to make a significant dent in our mounting piles of trash.
How we deal with trash has come a long way from the days of dumping and forgetting about it. Every generation has come up with improvements to our methods of disposal. Our landfills are safer than ever before, but there's always room for improvement. So ask yourself, what will your generation do? Will you be a part of the problem or part of the solution?